All right, so we'll go ahead and start our last section of notes for this unit. So this is going to be 6.5, and this is going to be called CPCTC. Okay, and the date that we're doing this is either the 26th of February or the 1st of March, depending on what period you have this class. And our objective for today is we're still talking about triangle congruence. It's been the theme of this entire unit, but specifically we have this new idea or theorem that we call CPCTC, excuse me, to prove some different things here. And we'll get into what all this means here. So first off, little review. You can choose to sketch this down, but you don't have to. I'm just going to kind of talk through this. If I'm looking at a diagram like this is saying if PR is congruent to TR and QR is congruent to SR, explain how you know that angle P is congruent to angle T. So if I'm looking at this here, I'm trying to figure out why that makes sense or how I know that. If I look at this here, I see I have these two congruent sides, and I'll go ahead and mark those, PR and TR. And then I also have these two sets of sides, QR and SR, and those are all going to be congruent to each other. And it's asking how would I know that these angles, P and T, would be congruent? Well, if we ask this question, it's not just apparent immediately. It's not like we're given any other information where we could say, you know, these are alternate interior angles or vertical angles or something like that. But what we do know, just by looking at it, is we do know those middles and these angles in the middle, are congruent. And so I know that triangle PRQ is congruent to triangle TRS, and the reason that I know this is I'm just going to say because of side angle side, right? We know we have two pairs of sides, and then those angles in the middle we know are congruent just by looking at them. Okay, those are vertical angles. So I know that these triangles are congruent. And remember, we've said the definition of something being, the two triangles being congruent is that if they're congruent, then all the little pieces are congruent as well. So I'm going to say since the triangles are congruent, and you can write this down if you'd like, but don't have to. I'm just saying since the triangles are congruent, then the pieces are congruent as well. And specifically the pieces that are in the same spot. Okay, so why do I know that angle P is congruent to angle T? Well, because they're both in the same spot. P and T are corresponding, and so that means that they're congruent. Okay, this is what leads us to this theorem here, which is what we call CPCTC. Jeez, I'm already messing it up, trying to say it multiple times. Okay, and the good news for this is the definition of it is just what all these letters stand for here. And it says this, it says corresponding, I'll go ahead and capitalize the first letter, corresponding parts of congruent triangles are congruent. Okay, corresponding parts of congruent triangles are always going to be congruent. And this is basically what we just said on this last example. We said once we prove that the triangles are congruent, all the little pieces here, P and T, S and Q, okay, and then the last pair of sides, PQ and ST. I know those marks are kind of sloppy, but all of those parts are now congruent as well. So that's my main end goal, is we're still trying to prove that triangles are congruent, but now we can kind of just add on this last little step. And we'll obviously talk about what that means in proofs. So first off, a little example here. Try not to move things around too much. Okay, I want you to take a second. I want you to sketch these two shapes for me here. And I'll save you a little bit of time here. There's some things that you can leave off. You don't need to worry about anything with X. Whoa. Try to get my pen back here. Maybe. All right, give me one sec, guys. I'm going to pause this and get this figured out here. All right, there we go. So a few things I'm going to cross out here is you don't need to include anything with X, and you don't need to include anything with W as well. So I want you to take a second. Just want you to pause your video and sketch this if you need to. Okay, so we're looking at this here. We're given that these polygons are congruent, and we want to try to use that to solve for Y and Z. And this is actually one of the problems that we did on a homework assignment or an exit ticket when we first started this unit. And we're using the same idea, except now we're just solving for a couple different variables here. So if I want to solve for Y, I notice I have these two angle measures here, Y plus 11 and 2Y minus 31. And if I pay attention to how the letters are written, I have angle D and angle T, and D and T should be corresponding. And so this is where we use this theorem, where we say if I've shown that the big shapes are congruent, then these little pieces also have to be congruent as well. So that means I can say 2y minus 31 equals y plus 11, because both those angles are in the same spot in their respective shapes. And now that I have this, I can go ahead and just solve. So there's multiple ways to do this. For instance, one way I could do this is just subtracting y from both sides. When I do that, I have 2y minus 1y, which is just y, and then minus 31 equals 11. And then last step here, add 31 to both sides. And I'm going to get y equals 11 plus 31, which is 42. Okay, so first one we found it. I'm just setting them equal to each other. Okay, next one here, it says we also want to solve for z. If I look at this, I have two expressions with z. I have 3z plus 10 and z plus 16, and we notice the same kind of thing. If I have side length DE and TU, if I look at my letters, DE matches up with TU. So since those match up, those are also going to be congruent as well. So I can just say 3z plus 10 equals z plus 16. And now that I have the setup, same thing as before, I can just do the algebra. So I can subtract z from both sides. When I do it on the right side, they cancel. And on the left side, I have 3z minus 1z. That is 2z plus 10 equals 16. Continue to solve, subtract 10 from both sides. When I do that here, I get 2z equals 16 minus 10, which is 6. And then last step, divide by 2 here. And we get z equals 6 divided by 2, or 3. Okay? So just notice this is how this theorem works. Once I say that the shapes are congruent, then all the little pieces I can say are congruent as well. Okay, that's the definition of congruent shapes. Okay, so now how can we use that in a proof? Because we know we've been doing a lot of proofs this unit here. So first one, or example 2 I should say, you can pause your video and sketch this if you'd like. But otherwise, once that is done, I can go ahead and set up my proof, statements and reasons. Statements and reasons here. Okay, I know the first step. This should just be like riding a bike by now. We know the first piece. Given information, we're told that LM is congruent to LP, and then NM is congruent to NP. Okay, so this is good because we've already got a lot of our information that we're going to need here. But notice the biggest difference between this proof and all the ones that we've done so far is we're not trying to prove, or our end goal is not trying to prove that triangles are congruent anymore, but that these angles are congruent, LNM and LNP. So if I want to try to show this here, we're still going to use that idea that we talked about, CPCTC. We're going to prove that the triangles are congruent first, and then we're going to kind of tack on this last step here. So if I'm looking at this proof, I want to ask myself the same two questions we always do. What do I know from my given information? Well, if I look at my given, I have two things that are saying that side lengths are congruent, and these are kind of already doing their job. So I don't need to really use much of that. Okay, so then we transition to our second question, which is what do I know by looking at my diagram? Well, we've seen this idea before. There's usually either a shared side or there's vertical angles, and in this case there is a shared side, LN. And so what I can say is I can say LN is congruent to LN. And I notice I can just keep those in the same order. I don't have to swap those around because if I look at my proof statement, LN and LN match up. Okay, and what is my reason for this? We've talked about this before. This is what we call the reflexive property. If something is congruent to itself. Okay, the reflexive property here. Okay, so I have this here. I've said LN is congruent to LN, and I marked it on my diagram. And notice we actually have enough information to say what we usually do. And so we're going to do that. We're going to say triangle LMN is congruent to triangle LPN. Okay, and I just chose those orders of the letters. You could reorder them different ways as long as the correct letters line up. Okay, and what is my reason for this? Well, if I look here, if I'm thinking back to the theorems that we have, this is just side, side, side. I've shown all three pairs of one side, or I'm sorry, all three pairs of sides in one triangle are congruent to all pairs of sides in the other triangle. And usually we'd be done here. We prove the triangles are congruent, we'd call it good. But this is where our last step comes in. Okay, this is where the difference is. What we're going to say now is we're going to say our last statement. We're just tacking this on as an extra piece. We're going to say our proof statement. angle LNM is congruent to angle LNP. Okay, it's just one extra step that I'm adding on to our proofs now. And then my reason for that, how do I know that these two pieces are congruent? Well, remember we talked about this. We said if the triangles are congruent, which we just proved that they were, if I can prove that the triangles are congruent, then all the little pieces are going to be congruent as well. And so this is what we call CPCTC. Okay, this last step is the only real thing that we're adding on here. Okay, it's the same process. The only difference is add in your last proof statement and throw in CPCTC. Okay, simple enough. All right, so one more proof to practice this, and then we'll be good for today. Again, for this example, you can pause your video and sketch this if you'd like. And then once you have that done, you can go ahead and set up your proof. So we have statements and reasons here. Okay, statements and reasons. Okay, and we're told a couple different things here in our given. So we'll go ahead and say given. We're told KM bisects an angle, bisects angle JML. And then we're also told angle J is congruent to angle L. Okay, simple enough, just copying all that down. And the good news is that first piece that we just said, J and L being congruent, that is marked for us already. So you want to make sure you mark that on your diagram if you haven't already. If I want to work through this proof, it's the same two questions every single time. First question, what do I know from my given information here? So I see this piece here, KM bisects this angle, and notice there's a couple different things that we could be talking about. It intersects down here and it intersects up here. So we're asking, does it bisect this angle up here, or does it bisect this line down here? And notice it's just telling us that it bisects the angle at the top. So if I take this angle and I bisect it, so I have the big angle JML, I bisect it or I cut it in half, that means these two little pieces here are going to be congruent. And so to name those, I would say JMK, so angle JMK is congruent to angle LMK. Because remember, I need to go in the same order as I did on the other one. So JMK and LMK are going to be congruent to each other. And how did I know that? Well, remember, it came from the fact that KM is bisecting this angle. So I'm going to say definition of, and since it's bisecting an angle, this is going to be angle bisector. Pay attention to those times. Is it bisecting an angle or is it bisecting a segment? Okay, and now that I've said this, I'll go ahead and mark it as well. Two angles marked right there. Okay, so we've said this here. This is good. And now we only really need one more thing. And so that leads us to our second question, which is, what do I know from the diagram? Okay, you notice I just kind of ask these same two questions over and over again, and this helps me work through my proofs. So what do I know from my diagram? Well, if I'm looking at this here, remember it's really only one of two options. Either there's a shared side or there's vertical angles. In this case, there is a shared side. MK is in both the triangles, so I can say it's congruent to itself. MK is congruent to MK. And just like before, I don't need to swap the order around here. I can just say it is congruent to itself. My reason is still the same we used on the last one. That is also the reflexive property. Something is congruent to itself, reflexive property. Okay, and I'll go ahead and mark that as well. And now that I've answered these two questions, I usually have enough information to say that the triangles are congruent. And in fact, I do. So I can say triangle JMK is congruent to triangle LMK. Okay, these two triangles are congruent. And what is my reason for that? This is why I mark up my picture as I go. I see I have two pairs of angles, one pair of sides, and the pair of sides is not in between the two angles. So this would be angle, angle, side. The pair of sides is not in between the two angles. Okay, so we've said this, and like I said, usually we'd be done here, but that's not what we're trying to prove. It wasn't asking us to prove that the triangles are congruent. It was asking us to prove that these two sides, JM and LM, were congruent to each other. So now I can say that. I can say JM is congruent to LM. And what is my reason? We said this before. The fact that we proved that the triangles are congruent means all the little pieces are congruent as well. So this is what we call CPCTC. So you'll notice on all these proofs, it's just this last step being added in. Write down your proof statement. Reason's always going to be the same. Reason's always going to be CPCTC. And you'll only be using this if you're trying to prove that sides or angles are congruent, not necessarily just the triangles. Okay? So that is the notes for today. Pretty straightforward, hopefully. And then the homework assignment for today is 6.5, and that should be posted on the class website or should be handed out to you. Okay, as always, if you guys have any questions, feel free to let me know. All right, thanks, guys.